Hi all. Today we are going to see some of the very basic concepts in physics, that's physical quantities and their units. Before going to the details, what's the meaning of the word a physical quantity? In everyday life, we will come across many type of quantities. Some of them are measurable, some of them are not measurable. All the measurable ones are called physical quantities. Every physical quantity should contain a unit. Without unit, there is no meaning in a physical quantity. Different type of units for physical quantities. There are different systems of units, but in our syllabus, we will be using the SI unit. The examples are given there, meter, kilogram. Those things are examples of SI unit. The other type of units we are not going to use anywhere in our A-level syllabus. All the physical quantities that you are going to see in this 2-year syllabus can be classified into two broad categories. They are either base or derived quantities. So the entire physical quantity you are going to see in these 2 years are either base quantities or derived quantities. From the name, from the word itself, you will know base means very fundamental. Means you cannot get the base quantities using anything else. They are very fundamental things. But derived quantities are obtained from the base quantities by combining the base quantities, like two of them, sometimes three of them. So there are actually 7 base quantities, but in our syllabus we will have only 6 base quantities. In Edexcel they accept only 6 base quantities, so there will be 6 base units. So we are going to see what are the 6 fundamental quantities from which you can make everything else. I'm going to write the SI base quantities and their units one by one. The first one, very familiar, length. The symbol I used here is L, but it can be D or S or anything similar. So there's no standard symbol for length or distance. But the unit is always meters and the short form is simple m. The next quantity, mass, is also very familiar. The symbol I'm using is simple m. Sometimes we do use capital M also for mass. The unit is kilogram or kg. The next one also very familiar, it's time. The symbol I use T. Seconds or S is the unit of time. These are the 3 base quantities that normally comes in the mechanics topic. That's mostly in the unit 1 topics. Then we have 3 more quantities from other topics. In unit 2 electricity, you have only just one base quantity, that is electric current. Symbol is capital I. It's a standard symbol for current and the unit is ampere, which is denoted by capital letter A. Capital letter A, you have to be very careful when you write the units. If you don't write in the correct format, you will not get any mark. For example, if the name of the unit is the name of a scientist, for example, ampere is a scientist. So if you are writing the name of a scientist, the symbol should be written in capital A. But if you wish to write the full word, full name like ampere, then the starting letter should be simple letter like you see in that presentation. So if you write the full name of a scientist, you have to start with simple letter, and if you write the symbol, you have to write capital letter. This is a rule, but don't try to write the full name, so it will cost you a lot of time and also there are chances to go wrong. So always use the symbol. For any unit, try to use the symbol rather than the full name. Then the next base quantity is coming from thermodynamics. That's in our syllabus, it's coming in unit 5. So temperature has different symbols. Sometimes we use theta also. The unit is Kelvin or degree. Kelvin is more scientific unit that you will know later. Symbol is K. Then the last one, amount of substance, which is normally denoted by simple n. So that's also a standard scientific notation, which is measured in moles, and the unit also mole. But the mole concept is not used that much nowadays in physics. So you will be mostly using the first 5 quantities what you see in the table. Okay, so make sure you by heart these 6 quantities so that you can express or you can write any other quantity in terms of these 6. So let's see how the other quantities are formed. So let's see how the derived quantities are formed from these base quantities. Derived quantities are formed as the product of the base quantity. Sometimes 2 base quantities, sometimes 3, sometimes many base quantities together form a derived quantity. So for example, this meter square. So meter and meter is meter square. It's the unit of area. Meter per second is the unit of velocity. So you are combining different base quantities to get a derived quantity. Like in velocity you have meter and second, that means distance and time. And sometimes we express the units in meter square, meter per second like that, but some quantities, even though they have a base unit, we give a special name like newtons, pascals, etc. They're mostly the names of scientists. So this is a general idea about derived quantities. Except the 6 quantities what you have seen, all other quantities what you are going to study in this 2 year are derived from those 6 quantities. So let's see how you derived each quantity from a base quantity. I will show some examples. Let's see the example of force. How force can be written as the combination of its base quantities. I'm taking force as the example because force will come in every topic. This quantity is repeated in every unit in physics. So let's see. One of the advantages, you don't have to worry about the equation because almost every equation is given. For example, the equation F equal to ma is already given in the formula sheet. You don't need to by heart that. Okay. So let's convert the unit of force. Already you know it's Newton. Let's convert the unit into the base things. For example, here force is made of 2 quantities, that is mass and acceleration. Now convert each one into its base units. For example, mass unit is kg. Acceleration is change in velocity over time. So it's meter per second square. So the base unit of force is kilogram meter second to the power of -2. So you can see the format I have written second to the power of -2. We don't use meter per square in our syllabus. In our topics we will be using s to the power of -2, this format. So you should be familiar with this format rather than meter bar square. Okay. So the SI base unit of force is kilogram meter s to the power of -2 or per second square. That's how you convert any unit. For example, this is the example of Newton converted to its base units. Like this, you can convert any derived quantity to its base quantities or to its base units. So let's see one more example. Pressure. Now I'm taking the example of pressure. So how you express pressure in terms of its base unit. For that you need the equation, but it will be there in the formula sheet. We just have to convert each term into its base things. So here I have to convert force into its base units, area into its base units. Force already we have seen kg ms minus 2. This is just now we have seen from the previous slide. That's why I'm directly taking like that. Otherwise you have to derive the base units of force. Okay, but Here already we know. So this is the first step, write all the units in position. Now the second step is check whether if you can cancel something or you can simplify the equation in some way. For example, here you see there's a meter on both numerator and denominator. In denominator there are 2 meters, that's meter square. So what you can do is just cancel 1 meter from both sides. So now it became like this, just 1 meter remaining. Now always we have to write the final answer in a single line, not as a fraction. So what I'm doing is I'm taking the m to the numerator, so it should become the reciprocal, m should become m to the power minus 1. So this is the SI base unit of pressure. So we have converted pascals into its base units. Like this you should be able to convert any physical quantity into the base quantities, okay, or base units. Now I will show you a table. This table has a list of many quantities, many derived quantities, and the equations. The equations are mostly they are in the formula sheet. Then they are base units and they are SI units. So the third column shows the base unit of each quantities. The fourth column is the single SI unit, the special names if there is any. For example, instead of writing kilogram meter square S minus 3 A minus 2, we could just write O. You don't need to by heart this entire table because the equations are already given. You can just make each base quantity using the equation. So let's see what's the point. Why do we do this? Why do we convert everything into base unit? Why can't we just use Newton instead of converting kg ms minus 2? So every time we have been using Newton, we never used kg ms minus 2. But let's see, is there any use of splitting a derived quantity into its base quantities? Actually, there are two uses. The first use is to check whether a given equation is possible. You may not know it's completely correct. Let's see that why it's like that. So you can check whether an equation is possible or not. That's one of the important use of breaking down things into base. The second use is to find unit of some quantity that's very new to you. You haven't seen that before. So to find the unit of unknown quantities, you can use this idea. These are the two uses and you will be tested for each of these uses in your exam. So let's see some examples. The first one, how to check whether an equation is possible or not. The basic idea is for any equation in physics to be possible, all the terms in the equation should have the same units. So let's see what's the meaning of this. You can always say 5 kg is equal to 3 kg plus 2 kg. So 5 kg is equal to 3 kg plus 2 kg, we know. If you see the units, every term contains the unit kg. If you say 5 kg is equal to 3 kg plus 2 meters, then it's completely wrong. So if an equation has to be correct in physics or possible in physics, then every term should be having the same unit, like kilogram in that example. But you will get more complicated examples. For the beginning, I am taking very simple example. This equation already you have seen in your O levels. This is the equation for motion. Then the S represents not distance, it's displacement. Okay, there's a big difference between distance and displacement. We will come to that later. U is velocity, not speed, and A is acceleration. So already you have seen or you might have used this equation before. Let's see whether it's a possible equation in physics. Already you know it's a possible equation, it's a correct equation in fact, But let's try this method. First of all, I have to identify what are the terms. So there are three terms in this equation. I'm putting in boxes. These are the three terms in this equation. I'm going to prove all of these terms have the same unit. Displacement, anyway, it's very familiar to you. The unit of displacement is meter. Now the next one, u into t, meter per second into second. So I can cancel second and second to the power of minus 1 because they are exactly opposite to each other. You get meters. Then half at square. You can see here I didn't check for half and I don't care about half because half is just a number. The numerical constants, they won't have any units like 1, 2, 3, 4. They don't have any units. So instead of half, even if you put 2 or 4, there won't be any change in the unit. Okay, so the numerical constants are not checked for units. That's why I was saying possible equation, not a correct equation. So we can only check whether an equation is possible or not. We can't check exactly whether the equation is correct. Anyway, so this is meter per second square into second square. There is s minus 2 and s square, so they cancel and again you get meters. Every term in this equation has the same unit. So we can say this is a possible equation in physics. Okay. Anyway, I took a very familiar example, but in the exam, that may be a very new equation or not a familiar equation. Okay. Let's see one more example. So this is some equation you are going to see in Unit 5, simple harmonic motion or pendulum, motion of a pendulum. The equation shows the time period of a pendulum. L is the length, G is the acceleration due to gravity, not just gravity. Gravity is just a phenomenon. You have to specify acceleration due to gravity. I'm going to check whether this equation is a possible equation or not. Okay. So what I need to prove is all the terms have the same unit. For example, left hand side, time. There's only one term there. It's just t. In right hand side also there's only one term. There is no plus or minus. If there's a plus or minus only, we will have different terms. But this is all multiplication. So it's just one term. So I'm going to prove the whole thing on the right hand side has the unit second. Length is meters. Acceleration is meter per second. I have just written every unit in place. The next step is trying to simplify. So I can cancel mass on both sides. Now when the second comes to the top, it will become second to the power 2. Now if you see square and square root are exactly opposite to each other. So whenever they come together, they will cancel and you get seconds again. It means both left hand and right hand side have the unit seconds. So this is a possible equation in physics. We can't say 100% correct because the 2 pi, we didn't check for 2 pi. Okay, it may be 4 pi sometimes. So that we can't tell 100% correct. We can only predict whether an equation is possible or not. Okay, so this is one of the use of converting to base so that you can cancel. As you see in this example, you can cancel many quantities if you write everything in base units. So let's go to the next use of writing into base unit, that is finding unit of to find the unit of an unknown quantity. For example, you know everything in an equation except one quantity. Then how are we going to find the unit of that unknown quantity? So let's take one example. Viscosity, the letter in red is a Greek letter called eta. viscosity of a fluid. It's actually the friction or the stickiness between layers in a fluid. For example, milk is more viscous than water. This viscous force is given by the equation 6 pi eta Rv, where F is the force, R is the radius of a sphere. Anyway, later you will see this quantity in detail. So now just look at the quantities. R is the radius and V is the velocity. To find the unit of an unknown quantity. For example, you know everything in equation except one quantity. How are we going to find the unit of that unknown quantity? Anyway, the equations will be already given in the formula sheet, so no need to worry about the equation you see there. Now let's see what I'm doing. The first step is make the unknown thing as the subject. So I'm keeping eta there and I'm bringing everything else to the other side. I got the equation in terms of eta, like eta as the subject. Now the next step is change everything into units. For example, force. I'm directly writing the equation of force because already from the previous topic I know the base unit of force, kgms minus 2, I already know. But otherwise you have to derive. Then radius, of course it's meter, velocity is meter per second. 6 pi, I didn't check for 6 pi because it's just a number, so just ignore 6 pi. This is the second step. I have written everything in place. Now the third step is trying to cancel. So you can see there are 2 meters in the denominator and 1 meter in the numerator. So you could cancel one of them. You can't cancel both from the denominator, okay? So only 1 meter will get cancelled from both sides. So my equation became like this. But I want in a single line. I don't want any fractions. So I'm going to take meter per second to the numerator. So let's see what happens to the meter per second when it goes from denominator to numerator. You just have to take the inverse. Meter per second will become m minus 1 s. So again, one more simplification. There is s minus 2 and s. Simply s means s to the power of 1. So there's an s minus 2, then s to the power 1. I'm solving them and finally I will get this kg m minus 1 s minus 1. So this is the base unit of eta. So you have converted eta unit into its base units. First of all, you have to make eta as a subject, then write the units of every quantity, then cancel anything if possible. Then finally you will get the base units of any quantity. Okay, so this is the second example where we use converting to base unit or why it's useful. Okay. Next, we are going to see what are prefixes for the units. Prefixes are used just for our convenience. For example, if you want to specify a very long distance, we use the word kilometers, not meters. Like that, it's just for our convenience, but in exams, you will have to convert these prefixes into the standard units. I mean the SI units. So let's see how can you convert the prefixes and what are the commonly used prefixes in physics. Let's see what are the prefixes that is commonly used in A levels and their symbol and the values. One of the most common prefix that you will come across in the A level syllabus is kilo, which is denoted by the symbol K and it has the value of 1000 or 10 to the power 3. Means wherever you see kilo, you can replace by 10 to the power 3 units or 1000 units. The exact opposite or reciprocal of kilo is milli. Milli is denoted by simple m. It has a value exactly inverse of kilo, that is 10 to the power minus 3. Or it's actually 1 by 1000, but it will be easier if you remember 10 to the power minus 3 for conversions. The next most common prefix is centi, which is used commonly with distance, not with other units like centimeters. It has a symbol C, simple C, and it has a value 10 to the power minus 2. Another one which you will come across a lot in A levels is mega, capital M, mega. So you might have heard megabytes. It's the same, capital M, it's 10 to the power 6. The exact reciprocal of that, opposite of that, is called micro, which is denoted by Greek letter mu, and has a value opposite of mega, which is 10 to the power minus 6. The next one is giga, capital G. Its value is 10 to the power 9, and the opposite one is nano, which is denoted by simple n and has a value 10 to the power minus 9. So giga and nano are exactly opposite things. Then the last ones that you will commonly use in A level is tera. It's like capital T, that terabyte hard disk and all you might have heard. It's just the same T. Value is 10 to the power 12. Then the opposite or the smaller one is called pico or pico, denoted by simple P, and it has a value 10 to the power minus 12. These are the most commonly used prefixes in your A level syllabus. The violet colored ones are the bigger ones, and the green colored ones are the smaller ones. Then last one more, let's say it's beta 10 to the power 15, but we don't use it commonly in A level. So just remember these are the commonly used prefixes in physics. Now let's see how can you convert these prefixes into standard units. Anyway, the value is given in the table, so it may not be difficult for you, but you will have to by heart the values for each prefix. Again, I'm using the same prefixes, but this time with an example of meter. So I'm going to show you how you can use all these prefixes with the unit meter and how can you convert into standard form. For example, if you have a value some kilometers, always what you can do is wherever you see kilo, you can just substitute as 10 to the power 3, that's 1000. So 1 kilometer is 10 to the power 3 meters. Like that, if you have centimeter, that centi, C, you can always write as 10 to the power minus 2. That's the value of C. So wherever you see these prefixes, just replace by their values. So for this, you will have to by heart the values of each prefix. So just replace the value, then you get the standard unit, milli, millimeter. So 1 milli, I'm converting, the other one is meter. I don't have to convert meter because it's a SI unit. Like that, you can convert every prefix into standard terms. So remember the value of each prefix and just replace by the value and put the unit correctly. Then you will get in standard form. Okay, so this is how you convert the prefixes into standard form. We will do some examples after this. But before that, there is one exception, or there is one quantity which you may get confused sometimes. Kilogram. So in the previous table you have seen kilometer is not the SI unit of distance. Meter is the SI unit, not kilometer. But when it comes to mass, kilogram is the SI unit, not grams. So there's a confusion there, but you have to always keep in mind kg is the SI unit of mass, not grams. So this is something different from all other quantities where kilo is already there in the SI unit. Okay, it's not there for any other quantities. So you have to treat it like a special quantity. and you have to convert like 1 kg is always 1000 gram or 10 to the power 3 gram, or 1 gram is 1 by 1000 kg. 1 by 1000 you can always write as 10 to the power minus 3. So wherever you see 1 gram, you can convert always as 10 to the power minus 3 kg. So a gram is equivalent to 10 to the power minus 3 kg. This is the conversion for gram to kg. So you have to treat it like a special case, not like the previous examples. Now we are going to see some questions, simple questions for this conversion. So let's see one by one. It's a simple one. Kilometers you have to convert to meter. As I told, kilometer. So just look at the unit kilometer. Meter no need to convert, it's a SI unit. So you just have to convert kilo. That's why it's written in red color I wrote. So kilo you can always replace as 10 to the power 3. Then just put kilo value there, you get standard unit. You don't need to write 3000 meters, you can just write 3 into 10 to the power 3 meters. Always put the mod in your calculator into scientific form with 3 significant figure. It's better so that it will be very easy for the calculations. To avoid the confusions, always use the calculator in scientific form. Okay, then let's go to the next example. 2 milligram you have to convert to kilogram. So 2 milligram I can write like 2 milli into gram. So this is I just splitted 2 milligram into parts. Now if you observe the quantity, none of them are in SI unit. Means you have to convert milli as well as gram. So there are two conversions coming. Milli also you have to convert, gram also you have to convert, because I want in kilogram. So first I am converting milli, that is 10 to the power minus 3. Then I am converting gram, that is 10 to the power minus 3 kilogram. So there are two conversions in this, milli and gram. Wherever you see milli, you can immediately replace by 10 to the power minus 3. Remember the value 2. 2 will not change. When you change the unit, the original value will not change. Okay, only the powers will change. So milli, I am writing as 10 to the power minus 3. Then gram, I can replace by 10 to the power minus 3 kilogram. This is the next step. Okay. So then I'm going again simplifying. There's a 10 to the power minus 3, again 10 to the power minus 3, and I'm multiplying. So you have to add the powers. That's a rule for multiplication. You have to add the powers. So minus 3 plus minus 3, you get minus 6. So together it will be 2 into 10 to the power minus 6 kilogram. So that's equivalent to 2 milligrams. Okay. Let's see other type of conversions. In this slide, we are going to see the conversions with powers like centimeter square to meter square or millimeter cube to meter cube. So if there's a power, what you have to do. So let's see, I'm again splitting into two parts. Just 8 centimeter square means 8 times centimeter square. Now, the only thing you need to convert in the given question is centi. Centi is not SI thing, it's a prefix. So I have to convert centi. So the centi I can write 10 to the power minus 2. So see the bracket there, centimeter has a bracket square. That square applicable only to centimeter, not to the 8. Okay, so centi I have converted and I just put the bracket as it is. So this is the next step. I converted centi into 10 to the power minus 2, nothing else. Now I am going to remove the bracket. In order to remove the bracket, I have to put the power, for example, 10 to the power minus 2 all square. So when you are squaring the power, you have to multiply the powers. For example, 10 to the power minus 2 all square, that minus 2 into 2 will be minus 4. So the answer will be 10 to the power minus 4 meter to the power 2 is called meter square. So this is how I removed the bracket. 10 to the power of minus 2 all square will become 10 to the power of minus 4. Then meter to the power 2 becomes meter square. So that bracket is now removed, and this is the answer. Now let's see how to convert if there are many prefixes coming in single equation. For example, it's not exactly a prefix but multiple units. Kilometer per hour to meter per second. This is a very common type of conversion you will come across, because practically the speedometer of vehicles will be calibrated in kilometer per hour, not meter per second. So you may come across this conversion a lot. I'm splitting into parts 45, then kilometer is there, hour is there. What you need to know is kilo also a prefix and hours also not as a unit. So I have to convert kilometer as well as hours. So one by one I am converting. Kilometer is 10 to the power of 3 meters. Kilo I am writing just like 10 to the power of 3. Then 1 hour is 60 into 60 seconds. 60 minutes, then 60 seconds. Okay, or 3600 seconds. But remember, there is a power minus 1. So I am not touching the power, it's just like that. So power I put there minus 1. Now let's see how to simplify this. So the first part, let it be there 45 into 10 to the power of 3 meters. Then 1660 is 3600. So you can directly do it in calculator, no need of a separate step, but I just want to show you how I obtain this. Now there's a minus 1. So you can do directly in the calculator like this. 3600 to the power minus 1 is practically 1 by 3600. Then second to the power of minus 1 will be s minus 1. Okay. So this is how you convert kilometer per hour to meter per second. Then let's see a little more complicated one. Gram per centimeter cube to kilogram per meter cube. It's a very common question that you will see in practicals. In ATP, I mean, so unit 3 and 6, this is a very common type of conversion. Measuring density of objects is a very repeated experiment in unit 3 as well as unit 6. So you should be very good in this conversion. Again, like we did in the previous part, I'm just separating. 2.5 is there, gram is there, then there's a centimeter to the power minus 3. Remember that power minus 3 is applicable only to centimeter. It's not applicable to grams, it's not applicable to 2.5. Now when you observe this equation, you can see you need to convert two things, gram as well as centi. So both are not SI units, both are prefixes. I have to convert both grams and centi. So I am converting both. Gram I can write as 10 to the power of minus 3 kg. Already we have by hearted these values. That's the only way you can directly do this. Gram is always equivalent to 10 to the power of minus 3 kg. So gram part I have converted. Now centi. Wherever you see centi, you can replace by 10 to the power of minus 2. So I just did that. Then put the power as it is. Okay. Now I'm going to remove the bracket. So it's a power thing. So you have to multiply minus 2 into minus 3. Minus 2 into minus 3 will result plus 6. Okay, let's see how the total equation becomes. So 2.4 into 10 to the power of minus 3, let it be there. 10 to the power of minus 2 to the power of minus 3. Together you get 10 to the power of 6. 10 to the power of minus 2 to the power minus 3, the answer will be 10 to the power 6. Then meter to the power minus 3, that is meter minus 3. Okay, so that's how I have removed the bracket. Now again, there's one more simplification there. You see a 10 to the power of minus 3 there and a 10 to the power of 6. It's a multiplication, so I had to add the powers. Minus 3 and 6 I had to add, you get plus 3. So the answer will become 2.5 into 10 to the power 3 kilogram per meter cube. I have brought all the units together and I have simplified all the 10 to the power things. You can do it directly even in the calculator, but no need, you can even manually add the powers. It's not a difficult calculation. So 2.5 into 10 to the power 3 kilogram per meter cube is the answer. In fact, it's a density of glass, a repeated value that you will see in your A-level syllabus. 2.5 into 10 to the power 3 kilogram per meter cube. So this is some examples how you convert single units or multiple units or squares. All of these are very important in your A-level syllabus, especially in practicals. Okay, so you should be very fast in converting units to standard units. So the reverse conversion from some meters to centimeter, that type of conversions are very rare here because we'll be always doing things in standard units. So always you should be able to convert to SI units. Okay, so that's the end of this topic, the conversion of units. The next topic